A traffic accident occurred in the 35 km/h speed limit zone on Decula Road, in which a 3,000 kilogram SUV rear-ended a 2,000 kilogram wagon that was stopped at a red light. The investigating police officer has asked for your help in determining what happened and what laws were broken. Note that the acceleration of the wagon with the brakes locked is -3 meters per second squared, and the acceleration of the SUV with the brakes locked is -2 meters per second squared. This is the diagram of the accident site. The green skid marks indicate the distance that the SUV traveled after the collision, which was 2 meters. The pink skid marks indicate the distance that the wagon traveled after the collision, which was 24 meters. We took the information that was given and split it up into 3 sections: before the collision, during and after the collision, and the breaking point. For the SUV, the given information is written in black, and for the wagon, the given information is written in gray. What is needed to be found is written in color. The initial velocities in the braking section is the same as the final velocities during the collision. To find the initial velocities in the braking section, we plug the given information for both vehicles into the equation v squared equals v naught squared plus 2a delta x. To find the velocity of the SUV before the collision, we used a work energy diagram and showed the masses and velocities that we knew for each box. We used the equation P equals mv and then solved for v, and we got 10.8 meters per second. To find out if the SUV was speeding, we had to convert kilometers per hour to meters per second. We multiplied 35 by 1,000 because that's how many meters are in a kilometer. Then we divided by 60 twice to figure out the speed limit, and we got that 35 kilometers per hour is equal to 9.72 meters per second. So the SUV was going over the speed limit by 1.08 meters per second. This is the SUV velocity time graph. It shows that the SUV was moving at a constant velocity, and then after the impact that it decreased to 0. This is the wagon velocity time graph, and it shows that the wagon had a velocity of 0 because it was stopped at the light, and then when the SUV hit, the velocity increased rapidly, then decreased to 0 after braking. To see if the collision was elastic or inelastic, we had to see if kinetic energy was conserved, which we found out was not after plugging in our information into the equation K equals 1/2 mv squared. Kinetic energy was not conserved, causing it to be inelastic. The work energy chart for the SUV shows that before the collision, it had a greater kinetic energy than it did afterwards. The work energy chart for the wagon shows that before the collision there was no kinetic or potential energy until the collision occurred, then it gained kinetic energy.